Welcome to a new episode on the Technomora channel. We really hope you will enjoy watching it and invite you to tell us what you think of it by leaving your reactions below the video. And now, please allow me to present your host, Technomora.
Why, thank you, Julie. So now let's jump right into the new episode. A couple of months ago, I restored this nice piece of equipment, which is a Sony TA-88 tuner. It's a nice vintage 70s tuner, and it works incredibly well. Now, I promised this tuner to somebody as a present, and I thought it would be a nice touch to give alongside with this tuner the appropriate equipment that goes with it, actually, and which would be the TA-88 Sony amplifier, which you see right there. Now, I bought this amplifier from the internet, on eBay to be more precise, and honestly, I don't know what's wrong with it. I think the seller said one of the channels isn't working, so we'll have to take a look at that. Now, visually, it looks in acceptable condition, so all the parts are there, all the knobs are there. There doesn't seem anything to be broken. So let me show you the back of it. So there you go. That's the back of the amplifier. So like I said, I thought it would be a nice present if I could give alongside with the tuner an amplifier that goes with it, and exactly the amplifier Sony intended to be used with the tuner all along. Alright, so I finished giving the cabinet of the Sony TA-88 amplifier a sanding all around, on the top as well, the sides, even the bottom and the back side of it I gave a sanding. I also reinforced it with some wood glue where I estimated it would be necessary to do so, because the wood was splitting a little bit and it was letting go of the sides and all of that. So yeah, I reinforced it with glue where necessary. What I then did was, you'll remember the corners, especially these top corners here, were rather damaged. So I repaired them with wood paste, and actually I repaired them first, and then I sanded everything, including the little metal grating at the top. Alright, so I used some wood paste to repair the obvious damages, and okay, you can still see the repairs, of course. I mean, it's not my intention to make it look brand new. I just want to make it look more or less, let's say, authentic. Yeah, and that's why I repaired the most obvious damages. Then I gave it a rub down with some moist cloth to take away all the grime and all the shavings and everything. And I think the cabinet is ready to get its first coating of varnish, and I'm going to use the varnish that I usually use. So I'm not endorsing this particular brand, but I've used it in the past and I was satisfied with the results. So what I'm going to do is I'm going to use these little rollers. Here's the handle. Alright. So I prefer to use rollers, in fact, like these, because it's less wasteful and it allows me to coat a surface more evenly than with a brush, because with a brush you'll always see some streaks in the paint or varnish that you apply, and with rollers like these that's far less likely. The only thing that really miffs me a bit about using these is that basically after one or maximum two coatings these rolls become unusable. So basically you have to throw them away after a couple of uses. And I mean immediate uses. So if you paint once, then put it somewhere to the side for 6 months, and then you would want to use it again, forget it. Okay, so yeah, these are, I would say, single use only, or maybe twice. Yeah. But even so, that being said, they are not so outrageously expensive, and they do allow for a nice result. So depending on how much varnish the wood actually absorbs, I will give it probably 2 coatings, maybe 3. Alright, so the cabinet is now stained properly. I'm just waiting for the last few little spots to cure, and then we'll apply a coating of clear lacquer over the whole cabinet. Now, well, obviously only on the outside, not on the inside. Now, the cabinet came out a bit darker than I had hoped for, but all in all the result is pretty nice. Yeah. Now, I did give the whole surface, top and sides, a light sanding with 400 grit emery paper, or sandpaper as people call that. And yeah, the result is pretty satisfying, I would say. So what's next? Well, giving it a clear coating, and then we proceed to investigate the electronic part. Here's another tip for you. So when you buy wood paste like this, yeah, you'll find that sometimes the wood paste starts to grow tough and rather dry and not so malleable anymore. So rather than let a whole tube go to waste, what you can do is open up the top and fill it up with a little bit of water, and I'm stressing the point, just a little bit of water, okay? So this is a tube of about, let's say, 3 inches high, okay? So what you need to do is fill it up with water till, let's say, about here, okay? So I'd say about a tenth of the tube. And what you do then is gently squeeze the tube so that most of the air goes out of the tube, and then you close it tightly up again like this. And then what you do is knead the whole tube for about 10 minutes, like I am doing right now. Yeah, kneading it up, okay? And when you feel, and when you don't hear any more squishing noises inside the tube, that means that all the water has been mixed with all of the paste, okay? And once that is done, the paste is good to be used again. Yeah, so that way you have a lot less waste. Now, you can repeat this only so many times. I mean, after a while, the wood paste, of course, will be diluted to so little, in fact, that it becomes unusable. But let's say over the space of a few months, you can use this trick until I'd say the tube is about half empty. And then you either use up whatever is left quickly, or you need to throw it away and buy a new tube. Alright, while the last coating of clear lacquer is drying on the cabinet of the Sony TA-88 amplifier, it's about time that we get a closer look at the electronic part of it. And well, we've already removed the cabinet, of course, from around the amplifier. What we're going to do next is to obviously disassemble the amplifier PCB by PCB and replace the electrolytics. I know some of you are rather impatient and would like it to see work, and so am I, but generally I resist the impulse to start up something if I'm unsure about its state. So rather than destroy a nice little amplifier that I'm going to give away as a present to somebody I really like, so rather than risking burning the electronics of the amplifier out of impatience, what I'm going to do next is I'm going to remove the PCBs, or at least swing them over to have a closer look, and once we've explored the interior of the amplifier, I'll start replacing all the electrolytics and any other part that might need replacing. Alright, so I removed the grid that covered this part of the amplifier, and a thing that I hadn't noticed before was that there is a sort of plastic sheet glued to the inside of that grill, and it looks like something that was factory made, so it is I think original. And I also think it's either anodized steel or copper clad steel. I don't think this is actually brass, although when you look at the cut in the metal, it certainly looks like brass. So yeah, it's possible that it's brass. I don't know. I didn't check it out with a magnet. Let's see. Oh, it's magnetic. Okay, so yes, it's steel. You see? Yeah, like I thought, it's steel which has been anodized. Okay, so all right. What I also did was I removed these two screws here, which were holding the grid in place, and then one single little screw with a washer at the bottom of the PCB, right here, right there. So normally I should be able to swing this PCB out either this way or that way, but I can't, because if you look closer, I'll give you some light. So you see this PCB here has two leads attached to it. So this one and this one here, and this one goes somewhere else. So before I can remove this PCB, I need to detach these leads here. Now, a good tip I want to give you is, if you're going to remove parts from a device and you're going to disconnect wires and such, always take plenty of pictures, alright? If you take a lot of pictures, especially of the spots on which you're going to work, it will save you a lot of trouble afterwards. I unsoldered the little board here from those three wires, the white, the black, and the red wire, and I managed to swing it outward like this, which is quite nice. This will allow me to replace the far more electrolytics. Let's see, 5, 6, 7, 8, 9, 11 electrolytics on this little board here. And then you have the driver board, or the actual amplifier board, which is here. And this one has 5 electrolytics. Alright, these little blue things here. So interestingly enough, whereas the tuner that I restored, the TA-88, was pretty hard to restore, Sony actually made an effort to make the electronic parts in the amplifier much more accessible for maintenance or repair. Alright, one board done, another board to go. This one. That should go fairly quickly. There are only 5 capacitors to replace. This board was 11 capacitors. Took me a little bit less than 40 minutes, all in all. Alright, now here's a little conundrum for you all. As you know by now, the power supply of the amplifier is hidden behind this thick, heavy steel shield. lightly see how to detach it. And I think some of you may have already found out why I just can't unscrew the whole damn thing and lift it out. Do you see it? Yeah, I'm pretty certain you spotted it by now. So, yeah, all the power transistors, the output power transistors, are screwed down to that heavy metal shield, this shield here, and they in turn are soldered to that large PCB at the back. So I'm looking at it from all sides and I'm guessing, but this is at this stage only a guess. I'm guessing what I need to do is to unscrew this screw here, and then I need to release this large PCB here from the chassis of the amplifier. I had to remove the two top braces, and I removed a couple of screws, you see them here, which connect the bottom of the back plate, yeah, to the lower part of the chassis, right here. And I needed to do that because if I hadn't, I would have had to force too much the whole PCB you see at the back there to move it out of the way. Let's see if I can give you a little bit more light. There you go. So you see the PCB, the power supply there at the back. And unfortunately, I mean, I suppose I could have removed the top three capacitors you see over there. So the two large ones are each 2200 microfarad, 25 volts. This one I don't know yet. So I could have removed those three without removing the back plane of the amplifier, but then right at the bottom of the power supply, I don't know if you can see it, but right over there where I'm pointing at, okay, so right down there, there's another capacitor right there, yeah, and I could only reach it if I was able to remove the large PCB at the back. And for that I needed to remove the back plane of the amplifier as well. And here is the exploder view of the insides of the amplifier. Alright? Obviously I haven't cleaned it yet, but we're getting there. So lots and lots and lots of wiring. And here you see the sliding potentiometers. Okay, so this is a front view of the amplifier. Okay. Front. Back. It'll be interesting to put it all together again without squeezing any wires or pinching them off. Alright, I gave the slider potentiometers as well as the rotary switch and the on-off switches of the amplifier a bit of cleaning with my contact cleaner over there. And I hooked it up to my two test speakers up there. Mind you, one of the speakers is not entirely working as it should. It does have a bit of clipping going on, but they'll do for a test. Yeah, and I hooked them up to the output of the amplifier, and I hooked up my smartphone to the input of the amplifier, and more precisely to the auxiliary input. So I reassembled temporarily the amplifier. Now there's just one board that I did not fully attach to the frame of the amplifier, yeah, which is the amplifier, the pre-amplifier board, which is this little board here. Now, it was my intention to give you a little demonstration of how the amplifier works, but it seems the amplifier has a problem after all. So, rather than see it as something bad, let's find something interesting in it. Obviously, we need to find out where the problem is, and the problem is horrible crackling. Now, I did set the volume sliders to absolute minimum. Okay, so the left and the right channel are on minimum. And I connected up temporarily with crocodile leads my test speakers, which you see up there, two lower speakers, to the output lugs of the amplifier. There is an input, a test input lead here, but really this doesn't really matter. It's not attached to any sort of output device. So, what is the problem? Well, like I said, a horrible kind of crackling emerges from the outputs of the amplifier without any sort of a signal being put into it. So let me show you, or rather listen to what I mean. Yeah, that intermittent, horrible crackling noise. Now, you can tell that by the volume of the crackling that more than likely, yeah, I'm not saying it is that way, but more than likely the output stage, the very output stage of the amplifier, and I mean by that the power output transistors you see down there, are okay. So what could it be? Well, I had a look at the schematic, and as I said already, this little board here is a preamp or a preamplification board. So in other words, all the signals that are input into this, the whole amplifier through these Kinch connectors, yeah, or RCA connectors at the back, pass through this little board first, are filtered, a bit amplified, and then are passed along these two wire looms you see here towards what I would call the driver section of the amplifier. Now you could say the driver section of the amplifier, so the upper part of that long board you see down there, is sort of extra amplification and filtering before it drives the power transistors down there. Okay? Now, fortunately for us, or maybe unfortunately, the future will tell us, those two parts of the amplifier are separate. So we can sort of roughly differentiate or try to localize the error by disconnecting the preamplification board from the amplification board down there. And we do that by the simple expedient of pulling loose these wires. Now, while I'm debugging the amplifier, I don't want to listen to that annoying crackling all the time. So I'm going to prepare the amplifier for investigation by attaching power resistors instead of speakers to the output, so that we can work in peace and quiet and trying to localize the problem. Alright, so we already can assume that the origin of the problem is probably not located in the preamplification board, since we disconnected it from the amplification board. Yeah? So the preamp is certainly not, well, at least in my opinion, the source of the problem. But to make our life a little bit easier, we need to find out which channel of the amplifier crackles. Is it both channels? Is it the left or is it the right channel? We don't know yet. So what I did is I connected the left channel to a speaker and the right channel to a power resistor. So let's switch the amplifier on again and see whether we can still hear that annoying crackling. There is some buzzing and crackling, but not very, very loud. Yeah? So there's obviously an issue there as well, or there might be an issue there, but it's certainly not as loud as it was before. Okay, so let's switch over the connectors and see whether we do get crackling on the right channel instead of on the left. So now I attached the right channel to the speaker, and I'm going to attach the left channel to the power resistor. Okay, the same power resistor. So there we go. Alright, so now it's the right channel attached to the speaker. Volume sliders are all the way down, so here we go. Yes, there's definitely crackling, more crackling on the right channel. So, what am I doing? I'm measuring the voltage between ground, which is actually attached to the common of the transformer, yeah, or the center tap of the secondary of the transformer, and it has, let's say, a ground between a positive and a negative voltage. Okay, so you can see on one end of the bridge rectifier measured over ground and one end of the bridge rectifier, you get plus 23 volts. Measured over ground and the other end of the bridge rectifier, you get minus 23 volts. Okay, so what am I doing now? I'm measuring the voltage between ground, that part here, that thick black line down there, and this point here, which is the cathode of the diode 301, which is that one over there. Alright, so I'm measuring, I should be getting there 23 volts, or close enough to that. Okay, so I hooked up a multimeter to the output of that diode, and I also hooked up my oscilloscope to the output of the diode. Now, I'm measuring a voltage right now, even though the amplifier is off. That's because one of the capacitors, and most probably this one right here, come on, focus, this one right here, C302, which is a 2200 microfarad, is discharging, slowly discharging. So disregard that voltage for now. Now, there is something strange going on. So if I switch on the amplifier, watch what the voltage does. So the voltage almost immediately jumps up to, say, 21.6 or 7. Now, the voltage is all over the place. It jumps around. It's very, very unsteady. Also, when you look at the oscilloscope, I don't know if you can see this, but sometimes you can see like weird unsteady spikes going towards the bottom of the oscilloscope screen. Yeah, I'm sure you can see them jumping around. No, that sawtooth you see is, I would say, a normal ripple on the output of the bridge rectifier, because obviously the large capacitor on that end is trying to suppress any ripple. Yeah, and only that ripple is only about, I would say, 100 millivolts or so. But every now and then there's a spike of several hundreds of millivolts. Yeah, out there you saw one just right there. And also when you look at the voltage, you know, it's actually reasonably unstable. Yeah, it dances around sometimes just a few hundred millivolts, sometimes just a tiny little bit. It's just unstable, and also it's way too low. Well, when I say way, it's about, I'd say, at the moment 1.2 volts too low. Yeah, because remember, it should be 23 volts, not 21.8 or whatsoever. So there is something strange going on there, and I don't know what the problem is. Is it the bridge rectifier itself that's causing the trouble? Or is it something beyond the bridge rectifier which is causing the problem? So, very interesting. We need to investigate further. I think I may have found the culprit who is creating all the crackling and such in the amplifier. You'll recall it's actually quite intermittent, and if I show you the graph on the scope, so what I'm monitoring actually right now is the output voltage of the bridge rectifier, okay, and that's fairly constant with a reasonably high, I would say, ripple, which of about 150 millivolts. It's not too high, but we'll have a look at it if we can improve that anyhow. So that's what I'm monitoring with the scope, okay? So what I'm monitoring actually right now with my multimeter is the voltage on the base of the output transistor of the right channel. And the voltage should be 600 millivolts. And actually right now it's closer to, let's say, 590 millivolts, something like that, but which is pretty close. Alright, so we'll call that okay. There's a slight variance in the voltage, but I'm guessing that has to do with temperature mainly. Now, notice this transistor here, the little green transistor right here, which I'm pointing at, okay? Now, this is called a pre-driver, and if you look on the schematic, it's actually this transistor here, right here, Q253. Alright, and Q253 is a 2SA678, a PNP actually. So, yeah, Q253 is called a pre-driver. Alright, now have a look at this. So, I've got some cold spray here. Alright, this is cold spray. And I'm going to spray the pre-driver, so the 2SA678, this one right here, with some cold spray, okay? And then we'll have a look at the graph on the oscilloscope, okay? So the voltage actually on the bridge rectifier. Alright? So let's have a look, and keep in mind the voltage on the base of the output transistor right now is very very close to 600 millivolts. Alright, so let's go now and spray the transistor. Have a look at the screen. Horrible, isn't it? And have a look at the voltage. That's what's happening on the base of the power transistor. So no wonder you're hearing that horrible, horrible crackling. Alright? So, and you can see the spikes on the voltages. Yeah, on the voltage of the bridge rectifier. So yeah, it's all over the place. It's really horrible. And you can tell the voltage on the base of the power transistor is jumping around. Yeah, and it's really horrible. But once the transistor starts to heat up again, say after a couple of minutes or so, it starts to function normally again. Okay, there. Now it functions pretty normally again. Still a slight variation in the base voltage of the power transistor, but yeah, it's stabilizing. Now look what happens when I spray the transistor again. So keep an eye on both the oscilloscope and the multimeter. Oh yeah, oh yeah. I think I may be in luck. Yeah. So I checked the specifications of the 2SA678, which is equivalent to the 2SA673. Okay, and these are the specifications, and I do not have this one, but I have what I think is to be the next best thing, which is a 2N5401, and you see two of them at the foreground. Okay, so in fact, if I read the specifications of the PMP 2N5401 correctly, it should be fairly close to the specifications of the 2SA673 or 2SA678. There is a single little bit of a tricky thing to it though. If you look carefully at the pinout of the 2SA673 or 2SA678, it's emitter collector base. Alright? Now, if you look at the pinout of the 2N5401, it's emitter base collector. So, base and collector are reversed in comparison to the 2SA673. So that might be a little bit tricky to mount, but I think all in all, this transistor, the 2N5401, might just do the trick. Alright, the replacement transistors are in the 2N5401s. Yeah. And this is the one for the right channel, right here. And that is the one for the left channel, right here. Okay. Just as before, I'm measuring the voltage output of the bridge rectifier on the scope. Alright. Now, replacing the transistors apparently didn't change anything in the ripple, and I didn't expect it to do so, to have any influence. But the base voltage has dropped a little bit. So instead of being, say, 590 millivolts, it's closer to, 575 millivolts rather. Which isn't dramatic. Now, have a look at this. So I'm going to spray this transistor with some cold spray and have a look at the signal on the scope. Nothing. The signal remains stable. The base voltage on the power transistor dropped a little bit, say by 30 millivolts or so. But you see, the transistor is quickly returning to normal temperature, functioning temperature. But the most important thing is the signal on the output transistor, on the on the output of the bridge rectifier stays nice and stable. Alright, so you could tell that it was really bad sound. So I'm looking for another possible source of the problem. Here's a little mystery for you guys. So I'm measuring on the preamp board the voltages around this particular transistor here, which is a PNP. Now, this particular model is a 2SA704 according to the schematic, alright? So that's Q102. Okay, so I'm measuring the voltage on the collector, and according to the schematic, the voltage here should be 0.2 volts, alright? So let me show you where I'm measuring. Let's see. So I'm measuring the voltage at the collector, and the voltage at the collector is here. Alright. Now look at what the voltage is doing. It's all over the place. I mean, literally, it's all over the place. And moreover, it's negative voltage. Kinda sounds a bit familiar to the problem we had on the amplifier board. Wouldn't you think? So wait a minute, what kind of a transistor was that caused us all that trouble? That's the same exact type of transistor that caused us all the problems on the amplifier board. That little green transistor right there I'm illuminating is the cause, I think, of all our trouble. You know, I'm shining my laser right at it. Alright, this one I think is the cause of a lot of trouble. Now, I can't be sure, of course, unless I lifted out the print board and I measure it. But I wouldn't be astonished if that transistor is causing us a lot of trouble. Alright, it would seem that replacing those little green tinted PNP transistors, namely the 2SA673 and the 2SA705, have done the trick of taking away all those, you could say, cracklings and all those intermittent transient spikes in voltages and signals that I was measuring. So yeah, what could be the cause of that? I don't know. Maybe a bad type of material or bad production method. But what is very apparent is, if you look at the transistors up close, is that the legs are completely oxidized. Let's see if we can shine a little more light on it. Yeah. So I don't know if you can see this, but you see the legs close up to the body of the transistor. They are completely black, absolutely black and completely oxidized. So I wouldn't be astonished if the oxidation were going up right into the case of the transistor and causing a lot of havoc with voltages and signals. So yeah, these transistors apparently needed to be replaced. Now, has this solved the problem? No, not yet. I'm still measuring some weird voltages in the preamp board, or on the preamp board actually, and I'm taking as a target for my measurements the replacement transistor here for the 2SA705, which, by the way, is a S8550 transistor. Okay, so that's the replacement for the 2SA705. And I'm measuring voltages around the pins of that particular transistor. Well, what can I say? I finally managed to repair the amplifier. There were a few unexpected things that I encountered, and I'm going to tell you those in a minute. But let me tell you, any number of really bad swear words are welling up in me right now, because this amplifier put me through hell and back again. But it works. It finally works. And possibly you'll laugh, but you know, I was looking and looking for all sorts of sources of why in Earth's name the sound of the amplifier wasn't good, until I finally realized that maybe the problem was not with the amplifier at all, but those. Yeah, those two things led me down the garden path, yeah, for quite a while, a couple of days actually, until I realized, but wait a minute, maybe the amplifier is functioning right after all. And I started measuring all the signals that came through the amplifier from input to output on my oscilloscope, and I saw nothing wrong with the signal. Absolutely nothing wrong with the signal. So that's when it started to dawn on me that maybe the problem or the problems with the amplifier were actually all solved, and that I was looking for a problem that wasn't there with the amplifier. So what did I do? Well, unfortunately, I do not have a couple of good hi-fi speakers. I mean, those are the only two I have. Yeah, they are vintage, but obviously, and I'm not going to say what I'm thinking about them right now, they are bad. But aside from those bloomin' speakers, I do have a guitar amplifier. Well, a small one of, I think, 15 watts output power. And that one has a good speaker. Now, let me let you listen to the music. Here we go.
It's getting serious on this track, fail.
Alright, now the right channel of the amplifier. Here we go. Now, if you think it's as simple as removing or replacing a few transistors and then you're done, well, no. That's not how you're going to fix this kind of amplifier. If you have to be aware, first of all, if you're going to follow along with me, you have to be aware that replacing a few parts in this case won't do it. If you replace one type of transistor by another so-called compatible type, you'll still have some work to get it to work properly. Mainly, I'm thinking about biasing a transistor. Yeah? Change one type of transistor for another, and you can bet your sweet bum you'll have to recalibrate, let's say, the biasing of the new transistor, which effectively means you'll have to use a slightly different value of resistor mainly around the base of the new transistor to make it perform as intended on the schematic. Okay, and to achieve that, you will have to read the schematic attentively and measure, do a lot of measuring to make sure that the voltages, especially around the transistors, do match up as closely as possible to the schematic. Obviously, I also replaced all of the electrolytics, and I even replaced a few of the resistors, as you can tell. You know, the blue resistors you see over there are all metal film resistors, instead of the carbon resistors, the original carbon resistors. I did that because, first of all, the resistors around there were, well, they didn't match up too well anymore with their rated value. Yeah, so they were about 10% or more off value. And I used metal film resistors because they are more stable under different temperature conditions, which should improve the working of the amplifier. Now, one big problem I had with this amplifier was that the slider, and especially the treble potentiometer, this one here, when I set it somewhere around in the middle, it seemed to short out the amplifier. Yeah, literally to short the amplifier, because I was monitoring the voltage of the power supply on this multimeter, and when I set the treble potentiometer somewhere around the middle, yeah, the voltage dropped dramatically. Now, I solved that problem in the sense that by adding a few resistors to the slider output of the potentiometer. So the slider output is this cable here and that cable over there. Okay, and I inserted a 6.8 kilo ohm resistor in the slider circuit, and that solved the problem. Now, obviously, the problem would be completely solved if I found an identical slider potentiometer like this one, yeah, and replace the old one, which is in here. These are rated for 50 kilo ohms, but actually they give a bit less than 44 kilo ohms. And that is why I used 6.8 kilo ohm resistors on the slider output, yeah, to compensate that lack of resistance in the slider potentiometer. And that seems to have solved that problem too. What I also did was obviously clean everything with contact cleaner, and the most number of repairs or replacement, if you wish, were done on the preamplification board. Yeah, I replaced in all 4 transistors on the preamp board and 2 transistors on the amp board. They were all those tiny little square green or black transistors. Well, here it is, completely assembled. The Sony TA-88, restored and cleaned up and repaired. And it's a nice little amplifier, I like it. And the sound is really nice. But I have to say Sony, let's say, did make a few mistakes when building this amplifier. Mostly they sourced really poor quality parts, and I'm thinking about the transistors mainly for producing this little tuner, amplifier I mean. But aside from, let's say, the poor quality of certain parts, mainly resistors and transistors, it's a really nice little amplifier, and it's compact. If you put the smartphone next to it, yeah, you can tell that it's not extremely large, and it looks surprisingly modern. I mean, even in the year 2020, this looks like a modern, retro-looking amplifier. And it plays nice too. And it's very discreet as well. I mean, if you switch it on, the only pilot light you see is the little light telling you which is the source of the sound. So in this case it's auxiliary, but if you put it on tuner, then the center light lights up, and then phono. Phono is for record player, okay. So yeah, it's a very, very nice little amplifier. There is one thing I should tell you, that is that if you're going to use the phono input, this input is really sensitive. So even the slightest bit of music output will create a blast out of the speakers, okay? So if you put it on phono, always start at lowest volume and then only very gradually push up the volume. Alright? Obviously there's no balance, because you can set the volume for each output channel, left or right, separately, okay? But like I said, it's a nice little tuner. The sound quality, I suppose, is good, although I have not so good hearing. I'm sure some audiophiles would say, well, its sound quality is more average-like. But I personally, I like the sound quality of it. And there you go. The cabinet has been restored, lacquered with semi-gloss lacquer, and completely cleaned and repaired. And I hope you enjoyed watching this video, and you'll give me a thumbs up, and if you haven't subscribed already, then please consider subscribing. So there you go. Thanks for watching.